Good morning, guys. It's Naveen joining the call. Can you guys hear me? Could you please type in the chat window? Thank you, Pravalika. So, hope you guys had a good weekend, guys. Let's go ahead and get started. Today, we'll start with a little bit of Spark and Scala. And we'll try to focus a little bit in depth into Spark and Scala. And we'll also try to focus on our certification AZ 900 and DP 900, guys. Okay. So during the morning times, I'll focus on the first half of the day, Spark and Scala, and then the second half of the day, we'll continue with our Azure certifications. Okay. So let's see. Let me bring this up. Get started. Stop the share one more time. Sharing it again. There you go. Everybody can see the screen, guys. Could you give me a quick yes, please? Okay. Thank you. Let me come back here. Just my participants window. Okay. So let's see what we have here, guys. Spark, okay. By any chance, do any of you recall what is the mantra of big data? What is big data, guys? Anybody? It is 3 V's. Good. The mantra of big data is 3 V's: volume, velocity, and variety. As simple as that. They are not just double or triple, but they are so huge that they are exponentially huge. In other words, they are to the power of something else. On a daily basis, we have the data growing in that order, guys. All right. And let's say come back here. So there is Spark. Spark was built on Scala. It is the fastest big data analytics framework. We spend some time. We'll go a little bit deep into this aspect. So one of the guys here is indicating that he's asking which is the fastest big data analytics framework. And here is the second guy. He says Spark is 100 times faster. If you recall, we discussed why Spark is 100 times faster than Hadoop. Can any one of you recall why Spark is 100 times faster, guys? Why is Spark 100 times faster than Hadoop? There is a subtle difference if you recall, guys. I will give you an example. See if you can recall the example of library and the assistants counting the book in the library. It handles large data. Even Spark is used for handling large data. But why is it faster than Hadoop? If you recall, it is in-memory computing framework. What is the meaning of in-memory, guys? When we say in-memory, where are the computations happening? Good answer, that's RAM. What is Cassandra, guys? We briefly discussed about it. What is Cassandra? It is like HBase, it is a, pardon me, a NoSQL database, a column/column family oriented database is what it is. How do you define a column family, guys? It is a group of columns, as simple as that. What do you think is MongoDB, guys? Anybody recall? If you recall, it is document-oriented database. MongoDB is document-oriented database. Cassandra is column-oriented database. And Hadoop is a big data analytics framework. Okay. And let's say Azure puts all these things together and calls them as what? Hadoop, Cassandra, and MongoDB. What does Azure? Puts these three of them together and calls them as something. What is that? Tough question. That is nothing but the storage. The storage component of the Azure cloud computing is the unstructured data goes in Hadoop, the structured data goes into Cassandra, or more precisely, the semi-structured data goes into Cassandra and MongoDB based on whether it is a column-oriented database versus, or column-oriented data versus document-oriented data. So what is it we use for storing structured data in Azure cloud, guys? Anybody recall? What do we use for storing structured data in Azure cloud? We use database, SQL database, MySQL database, or PostgreSQL database is what we use, okay? And let me come back here, back here, close this one, let me bring up my labs. And guys, one of you bring up the labs so that we can try to practice a little bit of Scala. Also, I'm also trying to log in here. Institute, say sign in, say, oops, save it. And let's come back here, say click on this one, back here, let's say close this one. Okay, so come back here. Okay, let's move ahead. Okay, so Spark was originally built on Scala, and we'll try to learn a little bit about Scala in the coming up days, guys. It is a general purpose framework. What is it? Spark is a general purpose framework. What is general purpose framework means? It means it can be used with big data, small data, medium data, and different kinds of data. Remember, Hadoop is like a hammer. It is only used for big data. If you have small amounts of data, generally they don't use Hadoop. They use normal technologies, traditional ways, the databases, data warehouses, and things like that. Okay, whereas Spark can be used even when you have big data, even when you have medium-sized data or small amounts of data. That is what it means by general purpose framework. Batch versus real-time or near real-time. Okay, near real-time or real-time are similar, they're real-time data. So batch means generally Hadoop. That is where when we have lots of data, huge data, we are working. In other words, in order to process the data, we need a certain period and we need a lot of time. That is when we use that is what is batch processing. Real-time processing is it happens at that point of time. So in batch processing, generally we're dealing with zillions of data. In other words, the size of the data is the volume of the data is very huge. In real-time data, it could be as simple as a single row or a record in a database. Imagine the stock prices. What was the stock price maybe last second, maybe last minute, last 1 hour back? One simple row could be, we will take that row and we will try to make a prediction. What is that? That is real-time processing. So here is an example. An application is submitted to local land transport office, and this is a registration procedure. OCR is being done, optical character recognition. From their application, they're trying to read all the data rather than typing it. National Motor Vehicle Registration Office, then sent to the Motor Vehicle Registration Office. Then, or in other words, more precisely, here is what is going on, guys. I missed this step. Here is an applicant. He is submitting an application for something like a driver's license. So he filled up his application, he gives it to the guy who sits, maybe the reception or somebody. He's feeding it to OCR. OCR is reading the data. Once it reads the data, it is being sent to the Motor Vehicle Registration Office. Then they're getting the certificate printed. Certificate is examined to make sure it is saying it is right and good and things like that. Then the certificate is issued. So all these things may not happen at one point of time. When the applicant gives the registration or the application, it may take a little bit of time. What is that? That's an example of batch processing. It doesn't happen at that point of time. And what is happening? They don't process every one applicant. At the end of the day, whatever the applications are received, they will generally take up all the applications that could be end of the day, or maybe that could be end of the week or month, and then they will try to process it. That's an example of batch processing. Everybody with me, guys? Quick yes, please. Real-time processing is where you swipe a credit card. If you swipe a card, it takes maybe 5 minutes to 10 minutes for you to get the response. Then what will happen? Nobody will use a credit card. Generally 5 to 10 seconds. In a matter of second or 2 seconds, generally we have the response and we are going. We're completing our purchase. What is that? That is real-time processing. What is happening when you swipe a credit card? What is happening is at that point of time, your data is being sent to the credit card bank or credit card department of the bank. They're getting your data verified. Do you have the balance or not? And immediately we're getting back the response. That is real-time processing. Everybody with me, guys? Quick yes, please. Okay, batch processing generally, that could be 20 minutes, 20 hours, 20 days, and things like that. It generally doesn't happen at that point of time. Whereas real-time processing is a few seconds. It needs to happen at that point of time, and there is nothing wrong or right about it. That is the nature of these processes. Swiping a credit card versus maybe a bank statement. We don't need a bank statement every day, every moment. Okay, we need a transaction information. Imagine you used a credit card. You spent 10 rupees or 100 rupees in a store. Immediately, we will get an SMS message saying that, hey, you paid this much for using your GPay, maybe PhonePe. What is that? That is real-time processing is what it is, guys. It needs to happen at that point of time in less amount of time and things like that. That is real-time processing. So general purpose means batch processing is when we are processing large amounts of data. Streaming is real-time processing. You take one row of data, you may predict the stock price. Imagine you're watching IPL or cricket. You, based on every ball, we can make a prediction. Whether somebody is going to hit a 4, or maybe he's going to get out, or maybe he's going to just score 1 or 2 runs. What is that? That is streaming, real-time. Interactive ad hoc is randomly. You have some data, you randomly try to generate a report which has specific columns. Maybe you want a report which has all the transactions which appear to be fraud, which seem to be fraud transactions. They don't seem to be right to you. So you're flagging them as fraud. That's a random report. It depends on business to business. So what do? We're doing this, all these kinds of things. That is generally general framework or a general purpose framework is what is Spark about. Everybody okay with this slide, guys? Quick yes, please. Okay, so next we can also do machine learning. The AI part of it. Spark can also be used with machine learning. The Spark provides the Scala API, it provides the PySpark API, it also integrates with the R. We can, from the Spark, we can call Scala, we can call Python, we can call R code, so that the data scientists can perform their machine learning tasks. Generally, we don't do machine learning tasks directly in the world of Hadoop. We either use Python or Scala is also a good candidate for that, guys. Okay, so again, text processing, natural language processing. Generally, whenever people talk about natural language processing, computer vision, speech recognition, audio recognition, video recognition, Python is the king. Python is the emperor. Everybody by default goes to Python. Most of the time it is PySpark. Spark, they use it for pre-processing, and Python, they use it for machine learning, finding hidden patterns and things like that. That's where Python takes over, guys. Okay, so Hadoop requires different tools of various workloads. It is not that Hadoop cannot do this, but in the world of Hadoop, everything needs to be translated into Mapreduce. Mapreduce, the mantra is nothing but our library with 1,000 assistants, 1,000 books in each shelf, 1,000 shelves, 1 million books, and our task is to count all the books in the library. So Hadoop has its own separate libraries or packages, but generally Hadoop is not fast enough, and rarely we have seen the clients using Hadoop for machine learning and things like that, guys. That's where most of the time they tend to use Databricks, Spark, on top of it, Python comes to your rescue, is what it is, guys. Okay, Mapreduce can only run batch jobs. In other words, Mapreduce is mostly used in the context of batch processing. is what it is about, guys, okay? And come back to Spark, it is fast. It is 10 to 100 times faster. Its speed achieved by leveraging in-memory computation across cluster, which means in 2013, they have taken 100 terabytes of data. They used close to 2000 machines and it took 72 minutes to sort the data. Sorting is a pretty compute intensive process. So, and sorting 100 terabytes of data is not a small thing. So Hadoop has taken 72 minutes with 2000 machines. Spark did the same thing in 23 minutes with 200 machines, is what it is, guys, okay? So not only the amount of resources it has taken is less, but also the amount of time. So faster performance is what it is. And why is it? It is achieving by leveraging in-memory computations. In other words, Hadoop uses the hard drive. Hard drive is one of the slowest component of the computer, whereas Spark uses the RAM. And RAM is one of the fastest components of the computer. So for processing, where Hadoop was using hard drive, Spark was using RAM, and that RAM is nothing but the in-memory. So we say it's an in-memory computation engine. Everybody with me, guys? Quick yes, please. Okay. It is flexible and easy to use. It can be deployed with standalone or integrated with Hadoop. We can use just Spark without Hadoop. It's a framework. It's like a package which we can install. And we can run, we can start working on the data that we have, even if it is not on Hadoop. Most of the time, if it is not on Hadoop, you don't need parallelization. It is not big data. Many of the good things that Hadoop brings in, you don't need them. Maybe you have small amounts of data or medium scale of data, or in other words, maybe you have a database or a data warehouse. Only all the data is there and you want to perform some kind of analytics on it. That's where you can use Spark. You can also use Spark. Even if you have huge amounts of data which is unstructured, which is maybe multiple terabytes and things like that, that's where also Spark comes to your rescue. Okay, so a standalone means without, it will work by itself, it can be used by itself. Integrated with Hadoop means it can be used with other frameworks, not just Hadoop, but many other frameworks it can be used. It offers a growing set of APIs. So again, we briefly discussed, it has its own graph API, it has its own SQL package API, and other kinds of API. We'll try to have a quick look at them. So in other words, there are different kind of packages which are inbuilt into Spark. We don't have to learn a different language. In the world of Hadoop, we would have to learn a different tool for everything. For machine learning, different tool. For graph, different tool. For here, everything is in the Spark package. So if you learn either Scala or Python, you can do everything just using the same knowledge is what it is, guys, okay? Scala development is straightforward and efficient. Scala is the most preferred language for Spark, and more than Python, it is preferred because it was built in Scala. Scala is nothing but Java only, and a higher level Java programming language, guys, okay? And that is the most preferred language. It is on Spark, but most of the world continues to use PySpark, guys, okay? Has been my observation. It is straightforward and efficient. Okay, so here is a quick example of Python. What we are writing in 2 lines of code in Python and Scala. In Java, we may end up writing, where is it? Somewhere here I have a screenshot, I'll show it to you. We will write multiple lines of code. We may end up writing the Mapreduce programs. We may end up writing 30 to 40 lines of code and things like that. So high productivity language support. We can use Python on Spark, Scala on Spark. We can also use PigHive on Spark. Everything will run faster because Spark, what it is doing is it is working with Hadoop. At the time of computation, it is not performing the computations or the processing on the hard drive, but on the RAM. So native support means it is natively supporting. By default, it is built-in support for these languages. Uses of closures, iterations, and other common language constructs to minimize code. These are the things that we will try to learn and understand as part of Scala in the coming up days. Everybody with me, guys? Quick yes, please. Okay. Interactive exploration of data for data scientists. So this is how the Scala interface will look like. We'll try to get into the lab and try to access that, guys. Okay, so one of you, if you also can go ahead and log into the lab and be ready, we'll just check that in a moment. It is interactive exploration for data scientists. No need to develop applications. So in other words, it's interactive. Just like Jupyter. Jupyter is interactive. You don't have to write a big program in small cells, short cells. We write our programs and it will work like that. We can also run Scala on Jupyter Notebook. And let's see, I have not tried on our Jupyter Notebook, but we'll give a try today and see, get a feel of it, guys. Okay. Developers can prototype application on live system as they build application. In other words, most of the time in the world of data analytics and things like that, we don't have to build big applications. We write small programs. These programs are nothing but what we're writing in the cells in Jupyter. And what do? We try to understand step by step. Or in the world of data analytics, they will make a lot of changes. Each change they will try to make one step at a time. And they will try to look at their results and continue to the next step, and they will go like that, guys. That is what they mean by running them interactively. And they don't need to build big applications, but write small codes, because most of the time it's the data scientists. The data scientists don't necessarily come from the software engineering or the programming background, where they're building big GUIs, complex GUIs and things like that. They come from more of a scripting background and things like that. That's why they made it easy for the people like data scientists also to work easily on big data. That's what is the objective of Spark and Scala is, guys. Okay, these are some advanced operations. If time permits, we'll look at all these things in Scala, and we'll try to understand how these things work, guys. Okay, and here is the 40 to 50 lines of code. The 40 to 50 lines of code that we are writing in Java is what we can write here. If you look at Python and Scala, they are almost similar. Okay, just because we are already in touch with Python, familiar with Python, Scala will become easy for you to learn. And what is 2 to 3 lines? Behind the scenes, Scala is generating 30 to 40 lines of code in Java. That's what it is doing. So it's like a higher level Java is what you can think. They say it is also a better side. A better Java is also what Scala is referred as, guys. Okay, but for some reason, it couldn't beat Python. Python still seems to be on the top and king, and things like that, guys. All right. So that is the thing. So now take a look at this. This is roughly 4, 5 or 6 lines of Scala code. What we are seeing here, 30 or 40 lines is really 5 or 6 lines in Scala code. Even if we look at Python, even if we were to write Python, it will be exactly, except what you're seeing, this val on the left-hand side. If you remove the val, that is nothing but the Python code, Spark code. Or in other words, Python on Spark is what it is. What we are doing in 5 to 6 lines of code would take 30 to 40 lines in Java code. That is what is the power of Python and Scala, guys. Everybody okay? Everybody quick, yes, please. Okay, give me one moment here. Let me try to see. Here is the console lab, Cloudera, let's say View Lab. I'm just gonna quickly log in here. Oh, sorry about that. Give me one moment. Okay, so back to subscription. Let me see. See if I can click on the Jupyter. I'm clicking on the Jupyter Hub guys, just in case you're accessing. Sharing the screen. Here's the Jupyter Hub. Slowing down, just one moment, guys. Okay, here is the screen. Let me click on Jupyter Hub. I see. Okay. Can you see my Jupyter window, guys? Niharika, Lokesh, can you give me a quick yes? You're able to see my Jupyter window. Okay. May I come back here. Back to subscription details, and let's see. Link hosting till data. What was the username? Did we have to enter the username and password? Weren't we directly getting in? Let's see. Login password. So let's say copy this one. Try this one. Big user one. Back here. Big user one. Paste it. Say save it. Invalid username. Labs. Okay. So Suresh or Niharika, Lavanya, anybody able to get into the Jupyter Hub?
Yes, Naveen.
Did you have to log in, Lavanya?
Yes, Naveen.
Is it the same login or is it a different login?
Same login.
Same login as, for me, it is big user one. What I logged into this portal.
For me, it's big data user 118.
Okay, then why is it not allowing me? Try big user one. So paste it. Say sign in. Save it. Username. Let me try one more time. So it's going to be big user one. Paste it here. Oh, got it. Okay. So let me come back here. Share screen. So there it is. So let's say here's new Python 3. Oh, I think the Scala, we should be able to execute Scala here. Maybe the Scala is not installed on this one, guys. If you notice here, ideally, if you say new Python 3, you should see a Scala, you should see an R Java if they've installed the appropriate packages and things like that, but it looks like they have not installed it. So let me come back here. Back to, let's say, web shell. Say, Lavanya, can you see my web shell?
No, Naveen. I'm only able to see Jupyter.
Okay. So oops, stop the shell. Share it. Shell box. Is the one. Sorry. Wait, let's try to run that. Oh. Okay. So type in Scala. We're in Scala. Lavanya, have you tried that, please?
Trying, Naveen.
Okay. So that's how we get into Scala. Now I'll come back here. Okay, so before I go into the details of the Scala, let me stop it here. Bring up this one. So this is how the Scala code is going to look like, and we'll try to understand the different things of Scala and things like that, guys. Okay, but at a slightly high level, Spark and Scala, they are easy. In other words, working with Spark and Scala is simple and easy. It already provides Hadoop integration. Ideally, the administrator will configure the right config files, and it can work with Hadoop. That's what it means, guys. Okay. Then it runs with Yarn. Yarn is nothing but Hadoop version 2. We don't need to worry about it. Again, if time permits, we'll try to discuss a little bit about it in the coming updates. Language support. The Spark works with R, Java, Scala, Python. These are the packages. MLlib, Spark, Streaming, GraphX are some of the packages which work with Spark. And again, they are in Python and also Scala, guys. Okay. Okay. So back to a little bit of big data. A quick review, just a quick review of big data and understand some aspects of big data. We have formally gone through these slides, so we'll not spend too much time, but a quick look. It is a term applied to data sets whose size is beyond the ability of commonly used software tools to capture, manage, and process the data within a tolerable amount of elapsed time. Which means, again, sometimes we may have big data, which is really, really huge, multiple terabytes of data. It sits on multiple servers and things like that. Maybe 100 terabytes or maybe thousands of terabytes of data we need to process. In such a case, the data is really, really huge. So we're calling it as big data. But notice here, we are saying it is sizes beyond the ability of commonly used software tools to capture. Capture means storage, but manage and process the data means processing the data. Sometimes the size of the data is very huge and the processing is huge, but sometimes the size of the data is very, very small, but the processing can be very, very huge. In such a case, the data is small, but the processing is huge. Even then, in such cases, we call that as big data. The data is not big here. Even though we are just referring to the data, the processing is big, so we call that as big data. And the storage and the compute are impacted or affected by the volume, the velocity, and the variety of the data. That is why the mantra of big data is 3 V's. Everybody okay with this slide, guys? Quick yes, please. Okay. Okay, so back to a little bit of terminology. Scale up is where we have one computer, one server, we have one hard drive, one CPU. Imagine we have 1 terabyte of data, we can use one server. But what if you have 2 terabytes of data? Well, scaling up is where you're adding another hard drive and CPU. You're trying to make a single server more powerful. But what will you do if you have 3 terabytes? You can add maybe 3 hard drives and 3 CPUs into a server. But what if you have 100 terabytes of data? It is not possible to increase the power of the server to 100 hard drives and 100 CPUs. This is called scaling up. Scaling up is where we're increasing the power of a single server. Okay, guys? Then what do? That's where Hadoop comes to our rescue. Hadoop comes in and says, hey, don't worry. I'm a framework, allows the distributed storage and processing we discussed in detail. Distributed storage, again, if you recall, the mantra of distributed storage is SDR. What is SDR, guys? Do you recall what is SDR? A split, distribute, and replicate, to be more precise. Okay, back to here, back to here, is what it is. And so that is where it comes across, it allows the big data to sit across clusters. What is the mantra of a cluster, guys? Mantra of a cluster? It is a group of racks. What are commodity computers, guys? Very good. Cheap servers. And what do we mean by simple programming model in the world of Hadoop, guys? Simple and cheap. Okay. What do you think a simple programming model means, guys? It is the hive and the pig. Hive will take simple SQL commands as input. Pig will take simple English-like statements or commands as input. What is the meaning of open source, guys? Free, short and sweet. Okay. Data management. What kind of data management do you think that Hadoop is doing? Is tough question. What kind of data management? What does data management mean? Okay, behind the scenes, when we have big data, putting it on multiple, splitting it, distributing it, replicating it, these things require some very, very advanced computer science knowledge. We need to understand multi-processing, multi-threading, multi-node communication, many, many complex things. Hadoop takes care of all these things. Okay, what do you think is the meaning of scale out, guys? What is the meaning of scale out? Scale out means add servers, add more servers, back to a library, add more resources. Scale out storage and distributed processing. Remember, distributed processing is what Mapreduce is. Not only the data is distributed, but the processing is also getting distributed. Distributing the data itself is a complex task. Distributed processing is a super complex task. You have to be a mechanical engineer to drive a car, which is distributed storage. When it comes to distributed processing, you have to be a rocket scientist to drive a car. In other words, it is much more complex than the distributed processing. Everybody okay with the slide, guys? Quick yes, please. Okay. So let's see, that is scale up. Scale up, the problem of scaling up is every computer or server, any computer or server has a limit. How many hard drives, how many CPUs, how components can be put into these things, there is a limit. Scale out is when you have more data, you add more servers. Okay, what can you do? If you have 3 terabytes, you can use 3 servers. If you have 100 of them, you can use 100 servers, or maybe 1,000 or maybe 10,000. What is that? That is also called horizontal scalability. Scale out or horizontal scalability. So in other words, what is the advantage? There is no limit. The vertical scaling is where we are scaling up. There is always a limit. You cannot put unlimited number of components into a single computer, but we can have unlimited number of computers or servers working with each other. That is what is horizontal scaling. Everybody catching the point, guys? Quick yes, please. Okay, so back to Hadoop. Remember, recall Hadoop is, if we want to read 1 terabyte of data, the advantage of Hadoop is, if we have one machine which will take 43 minutes, then 10 machines can be done. 10 machines can do the same job in 4.3 minutes. What is Hadoop? Remember, Hadoop is a distributed file system. What is a distributed file system, guys? A group of computers. They are acting like a single computer. They are not single computer, but they are acting. That is what is the magic of Hadoop. Okay, so again, replication. If we have a file, we are splitting it into 3 blocks. What's happening? This block is getting split. Now it is getting saved and replicated. So split, distribute, and replicate. Split, now this is distribute, replicate. Distribute, replicate. Distribute is where we are putting the first one. Replicate is where we are putting the third one, second and the third one. And notice each of the color, the single, each rack has one in one of them, and two are there in an additional one. That is also a further optimization of how the data is getting saved, and all these things are being taken care of by Hadoop. We don't have to worry about it. Everybody with me, guys? Quick yes, please. So can anybody explain me what is data locality, guys? Moving the code to the data. Go back to the example of our library. We have assistants. Assistants go to the place where the shelf is and they count the books. We don't move the shelf to the assistant. The assistant is the one who is doing the processing. He is the code. He goes to the place. The shelf is the server. The books are the data. The books are sitting in the shelf. The data is sitting in the server. So what is it? Data is local. That is called data locality. And remember, all the assistants are working independent of each other and they're parallel. They're working parallelly. So if one of the workers or the assistant stops working, the other assistants are not impacted. They don't have to stop their work, which means parallelization is built into the framework. Everybody with me? Quick yes, please. And all this is taken care of by the Mapreduce framework. So distributed file system is taking care of the distributed storage. Mapreduce is taking care of the distributed processing part of it, guys. Okay. So again, a formal definition of Mapreduce. It's internally referred as a software framework. It is processing vast amounts of data, parallelization, big data, multiple computers, all these things are taken care of by Mapreduce. We don't have to write the code. In other words, developers were manually writing the code when they wanted to work with big data. With Hadoop and Mapreduce, we don't have to work with the. We don't have to write the code. That is what Hadoop and Mapreduce is saying, guys. Okay. So Google was already using this 25, 30 years back. After a quarter of a century, many people are trying to copy Google and do what they're doing. Why are we trying to copy Google, guys? Do any of you recall? Tough question. After a quarter of a century, still companies are trying to do what Google is doing. Why? Because they are successful. Successful in what? Successful in working with big data. Today, because of the internet, everybody is able to collect big data, lots of data. And what do they want to do? Well, they are saying Google is successfully able to process the amounts of big data and things like that. So a combination of the map and reduce models. So again, the Mapreduce is nothing but map, shuffle, and reduce. Whenever we refer to Mapreduce or anybody refers to Mapreduce, behind the scenes, you keep in mind the example of the library, how the assistants are going to the shelf and counting the books. Then the college intern comes, takes the data and he transfers it. At the time of transferring it, he's also grouping and sorting. So this is called shuffling. The mantra of shuffling, if you recall, tough one, is TGS, transfer, group, and sort. That is a college intern. Then the last step is the reducer step, where there is another assistant. He's just summing up how many books and he has the final result. So whenever people say map reduce, it is actually map, shuffle, and reduce, but they will refer it as map reduce. And I want you to keep the example of the library in the mind, guys. Okay. It is highly scalable. What do we mean by it is highly scalable, guys? Can anyone tell me? It's a simple answer at this stage. And the hint is itself on the screen. Ability? What ability? More precisely, if the number of servers or the computers increases as the data is increasing, what do? The framework is automatically taking care of the processing. We don't have to write the code again. Otherwise, every time you have the data increasing, if you have to write the code, that becomes a very, very complex process. That's what is scalable, guys, okay? So many small machines can be used to process the jobs. What do you think is the meaning of small machines here? You have just said that it is nothing but the commodity servers. They are cheap servers. They're not very powerful servers. They're not very reliable servers. So that's what they mean, guys, okay? Programming languages supported by Java, Python, and things means we can write Mapreduce programs in Java, Python, Ruby, Scala, C++, also, if it is needed and things like that, guys, okay? That's what the framework supports. What is this? This is before Spark. In other words, when Hadoop came in, this is the process they were following. They were writing Mapreduce programs for anything and everything. But what is the problem? Thinking in terms of Mapreduce. So there it is. Dear Bear River. That is library with 3 shelves. The first step is mapping. We're taking each book, mapping. And assistant 2, assistant 3. 3 mappers. Then we are transferring the data. This is where our college intern is grouping it and sorting it. B, C, D, R. Then this is being handed over to the reducer, assistant. So that guy is just summing up. Instead of sum, he can do an average, a min, max, or maybe perform a complex machine learning algorithm. That depends on the requirements and the business that we are into and things like that, guys. Okay, that is reducing step. And what is the reducer assistants after they're done? They give you the final. So what is this? This is like the number of books. Each word is like a book. We're counting the books in the library. Everybody with me, guys? Quick, yes, please. Everybody able to recall that example? That's an important example. Okay, what do you, okay, maybe that's a tough question. Keys and values. In the world of Mapreduce, we talk everything in terms of key values. What is that? That's a complexity. Mapreduce framework or Hadoop is indirectly forcing us to think in terms of keys and values. What if you are into an aeronautical domain, aerospace domain? You will not be able to take your data and translate that or think in terms of keys and values. What is that? That is what Mapreduce or the problem with Hadoop is. You have to think everything in terms of Mapreduce. Thinking in terms of everything in Mapreduce is nothing but thinking everything in terms of keys and values. We cannot think everything in terms of keys and values in different domains. We can think it, but it will become complicated. It may also become overcomplicated. What is that? That's a problem with Mapreduce. Okay, so they say keys and values is the language of Mapreduce. It is the structure, everything, anything on the left hand side is the key, remaining things on the right hand side. Or in other words, the first thing on the left hand side is the key, and the remaining things on the right hand side are referred as the value. So everything is being talked in terms of keys and values. Okay, so the problem, so again, word count. Word count is counting the words in a document. The document could be a book. What do? We are taking, so in the world of big data, we have hundreds and thousands and millions of documents like that. What should we do? Imagine our task is to count how many times a word is occurring or appearing. What is that? That is nothing but word count. In a real world, what happens, guys? In any day, imagine there is a new movie getting released. There are millions of users around the world. They watch the movie, they provide the reviews. The producer may be interested in understanding if the audience have liked the movie. The hero may be interested in understanding if they have liked the hero part of it or maybe the other part of it and things like that. What is it? Well, every tweet, every comment that is being talked about on the internet is like a document. So what do we have? We have millions and millions of documents. In the world of big data, what do? We take these millions and millions of reviews or documents and we try to find which word is appearing most. Let us say the word good. Bahubali 3 or maybe Bahubali 4 got released, and the word good is appearing many times. That means it's an indicative of a positive sentiment, is what it is. What is that? That is an example where examples of word count will come. If it is a small file, a simple file, writing a program which will count the number of words in a book or in a file is a very simple program. But the same simple program, when you're dealing with data which sits on hundreds and thousands of computers, may end up being very, very complex. Everybody with me, guys? Quick yes, please. The word count program is in itself a very simple program, but when we have large quantity of data or amount of data, the simple program which works may not work on the big data. Okay, so what do? We divide and conquer. In other words, map and reduce. Mapping is where we are splitting and distributing the data. Once we distribute the data, we are going and performing we're sending the code, not we, but the framework is sending the code to the place where the data is and doing the processing. That is again what the map, shuffle, and reduce is, guys. And again, if you recall, we discussed about this example. This is an example of log data. What happens in log data, guys? We have the IP address. We have many other things of the way the requests are coming from. The IP address where a request started, the date and time, the URL, and so on. So in other words, in real world, generally, when you have large businesses and enterprises, their log files will end up in being multiple terabytes in just a few hours or in just a few days. And many times what the management wants to do is they want to analyze their log files and understand some useful insights. That is where the Hadoop is coming to the picture with help of distributed storage and distributed processing. So these are some an example of log files. What we are doing is we want to find the URL frequencies. How many times is each URL happening? Now, if you think in terms of map and reduce, here's the map. We are taking this line. We are only selecting those words which are starting with HTTP. That will be your mapping function that we will write in the code. Then here's a little bit of optimization going on. And then we will pass it on to reduce. Reducer is saying, hey, from CNN.com, it looks like 1,000 requests have come. From Yahoo.com, 5,000 requests have come. Which means maybe our ad seems to be working better, doing a better job when we are advertising on Yahoo.com rather than CNN.com. So imagine a company was advertising on CNN and Yahoo. They want to understand where their traffic is coming mostly, and suddenly they realize more traffic is coming from Yahoo. Maybe they should stop CNN. What is this? This is an example of an insight. What are they doing? They're taking this insight, they're understanding, they're digesting, and they are trying to optimize, make a decision so that their costs are low and benefits are high. Everybody catching that, guys? Quick yes, please. So Spark and Scala is going to be slightly heavy theoretically, guys. Just bear with me. Gentlemen, ladies, everybody doing okay? Okay, let's take a short 5-minute break, guys. Okay, yes, are you back? Can you give me a quick yes? Okay, continue the journey. So there it is, guys. There's the process of mapping and reduce. We are extracting the URLs. We are only extracting the URLs here, not the IP address or the date and the time. And what we get is how many requests. This is 1,000 requests coming from CNN.com versus 5,000, which means more traffic is coming from Yahoo.com website. What is that? That's an example of an insight. Based on that insight, a business may make a decision that, hey, we will continue to advertise on Yahoo.com rather than CNN.com. What are we doing? We're taking some decisions. Generally, that is what is the process about, guys. Okay. The next one. Okay. So back to Mapreduce. There are some problems in Mapreduce. It is difficult. Mapreduce is complex. It needs abstractions, constantly thinking, constantly translating everything as a key. And the value is not easy. It can get super complex. It does not have an interactive mode. In other words, in the earlier days, before Pig and Have, everything was being written as a Java Mapreduce job. You cannot run one step at a time and see what is happening. Based on that step, you want to decide what you want to do in the second step. So that will take time. It is not very productive. That is where Pig and Hive have been introduced. We can run one step at one time. Streaming used for generating batch reports, and that helpful in finding insights to historical queries. So again, Mapreduce was more geared towards batch processing, not for streaming. Performance, it does not leverage the memory of the cluster. So in other words, the optimization, performance optimization needs to be done by us. It does not take full advantage. Latency, it is disk oriented completely. So everything, all the processing happens on the disk. Ease of coding, it is tough, complex and lengthy. What are these? These are the problems of Mapreduce. What is Mapreduce? Mapreduce is a framework for distributed processing. That's where, so here is Mapreduce again. We have data on the disk. What we are doing is we read it, not we, the framework reads it from the disk, process it on the disk. At the time of processing, it is using the disk. Then in the reduce step also it is using the disk to process the data and then saves the output to the data. That's where Spark comes in. The input data and the output data can be on the disk, but at the time of processing, it is saving it into the RAM or the memory. As a result of that, we are able to get 100 times faster performance. That is what is in-memory computing. That is what is in Spark. So the problem of Mapreduce has been addressed. All these problems which are in Mapreduce have been taken care of by the Spark. What does Spark do? Spark is easy compared to the Mapreduce, and we'll try to understand that. It is interactive. We can write one step at one time, just like Pig and Hive programs, and just like Python programs, to be more precise. Streaming is also supported. In other words, for big data, for medium data, for even small amounts of data, we can use Spark streaming. That's a separate package. It achieves 100 times faster performance than Hadoop. Latency, in-memory computing ensures low latency. Low latency means delay. Because we are performing in memory, we're able to get low latency, which is low delay. Low delay means faster performance. Not only across one computer, but across all the other computers. Remember, all the computers or the servers are called the workers. The architecture of Hadoop is master worker architecture. And it becomes much more simple and easy to work with Mapreduce. Spark makes it easy to work with Mapreduce is what it is. That's what we'll try to understand, guys. Okay. So back to Hadoop and big data. It is reliable. These are the advantages of Hadoop. It is economical, lowers the cost, scalable. You can add more servers without changing the code. It is flexible. It gives you different ways of working with the data, whether it is Hive, Pig, and things like that. Okay. So that's where Spark comes in. Spark is generally used on top of Hadoop. For storage, they use Hadoop. For processing, most of the businesses are using Spark. So the one in the blue colors is what is the advantage of the Spark. The one in the orange colors is what is the advantage of the Hadoop. We're getting best of both the worlds in the world of big data. Okay, and Spark, when they refer to Spark, It is a group of packages. So in Python, also Anaconda is acting like a group of packages. It is a distribution which has all the packages built into it. So Spark is also similar to Anaconda, where it is giving us a package of Spark SQL to work with structured data, Spark Streaming to work with real-time data, and PySpark and Spark are, we can, by default, Spark works in Scala, but we can also write the programs in Python and R. MLlib is a package for machine learning. GraphX is a package for graph-like data. Then we have Spark Core. That is what is the core or the main part of the Spark is, and it has a built-in standalone scheduler, which means if you don't have Hadoop, then Spark works uses standalone scheduler by default. But if you have Hadoop, there are configuration files where we need to go and change and say, hey, here is the Hadoop name node and the job tracker or the resource manager, IP addresses, and Spark will continue to work with minimal changes. So Yarn and Mesos are called cluster managers. Okay, so this is a high-level architecture of the packages of Spark. And what is happening is, ideally, in the world of data analytics, everything is a different project and a step. You first acquire the data, you store the data, you vectorize the data. Those are slightly advanced stages. Then you try to build a model, make a prediction, and then you try to present your results. For all these things, initially they were using different packages: PyMongo, Pandas, scikit-learn, Pickle, and Flask. But what Spark does is, whether you use Python or Scala, we're unifying them into one package. When we install Spark, all these things are coming together. All this group of packages are there. And by learning one, we're able to do all these things in just learning one technology or one tool, and not learn a different technology or not learn a different terminology and an API for everything. That is what is the meaning of unified platform. Okay, guys, slightly deep on there. Everybody okay so far? Quick yes, please. Okay. So again, advantages of unified stack. It enables various workloads to be combined, which means it works with big data and small data. Additional components can be integrated easily. So there are more packages which are being developed in Spark to work with different scenarios and things like that. That is another advantage. We can easily install them and work with them. Lower level stack enhancements impact higher level stack components. So whatever the improvements and the optimizations, performance optimizations and other kinds of optimizations they are doing and they're working at a low level, everybody else is automatically getting it. They're cost efficient. In other words, it is also reducing the cost. It allows leveraging the different workloads provided by the Spark. Again, it works with different kinds of different kinds of data is what it is, guys. Okay. Now here is a slightly advanced concept in Spark. We'll try to see if we can simplify it, and then we'll see, move on to Scala and things like that, guys. So here is resilient distributed data set. It is nothing but it is like a big data set. It is like a table in Hive. And what is special about it? It is, in the world of Spark, they're immutable. They're partition and reusable. RDDs. What is an RDD? It's like a big data set. Think of it like a big data frame. Think of it like a Hive data frame. They're immutable means once you create a big data frame, you cannot change it. Their partition means, because if you recall, in HDFS, a data set or a file is split into different blocks. A file is a group of blocks. Spark calls them as partitions. The same concept, but a slightly different terminology. They're reusable. You don't change them, you can reuse them multiple times. As simple as that, guys. Okay. So these are some of the functions which are provided by Scala and PySpark. These are the ones which we'll try to get a feel of and try to, which will help us in understanding how the Scala, the Spark work together, guys. Okay. So the map and reduce. In the world of map and reduce, in the world of Hadoop, to be more precise, there were only two functions, map and reduce. But Spark gives you tens and tens of other functions written in Scala and PySpark. And these are the other functions that we need to have an idea, guys. Okay. So behind the scenes, we need to have an idea. Every RDD is a directed acyclic graph. In other words, every RDD, which is nothing but an object in Spark, is nothing but a architectural plan. The architectural plan is called a directed acyclic graph. Back to our object-oriented concepts, if you recall. And a class is an architectural plan or a blueprint. An object is a house. So RDD is a house, is an object, is a big data set. Behind the scenes, it's an architectural plan. That is called as a directed acyclic graph. DAGs, D-A-G, is what they call. Okay, so behind the scenes, it is a group of steps. Each step is a stage. Each stage is a group of activities. Each activity is a group of steps. In other words, the output of stage one, step one is going to step two to three. Sometimes maybe the output of step one is also going to step three. Then from there, this is the next step. This is the next step. So what is this one? This is a graph. A graph where the output of one step can go to any step. It is acyclic. It is not cyclic. Cyclic means it goes like a cycle. This is acyclic, guys. Anywhere, from anywhere, you can go to anywhere. So what is this? Every time we build an object in Spark, it builds a graph like this. And what is that? That's an RDD. RDD is a big file or a big data set. Behind the scenes, it's a group of blocks or a group of partitions. The data set can be in file, database, stream, or collection. What is it? Count is a function, is like a method. When you say count on that file, it gives you 100. It is indicating how many records are there in that file. What are partitions? Partitions are a group of records. Internally, a partition is a group of records. A data set or a file is a group of partitions. So server one can have two partitions. Each partition is a group of records. And based on the size of the data, the file or the data can sit on multiple files. So if server one goes down, then somewhere else, the data, server two will take up the responsibility and try to process the data which was available on server one. If you recall, that is what is called fault tolerance. Fault tolerance not only from a storage point of view, but also from a processing point of view is what it is, guys, okay? So Spark components are designed to be efficient and integrated. All these things are being done, being taken care of by Spark from a processing standpoint. We don't have to worry about them. The various workloads can be leveraged either independently or in combination. Whether you want to work with big data, small data, or a combination of both of them, how you want to sequence them is up to you. And at a slightly high level, Spark is with mainly three components: cluster manager, Spark core, and Spark built-in libraries, guys, okay? So here is the Spark framework. We have Spark core. The standalone Yarn and Mesos are called the cluster managers. We just need to have a quick idea about these things. We will not go too much into detail, guys, but just bear with me here. So one of the most important thing, or cluster managers is an important thing, because behind the scenes, when Spark works with big data, the cluster manager part of it is taking care of the communication. Whether you work with one node or server, whether you work with 100 or 1,000 or 10,000 servers, the cluster managers are taking care of it. We don't have to worry about it. They can operate on several thousand nodes. Standalone scheduler cluster manager included with the Spark. It comes with the Spark. Yarn and Mesos cluster managers used to deploy Spark on a shared cluster. So if you work with Hadoop and other big data frameworks, that's where Yarn and Mesos will come into the picture. But again, a quick idea about it, guys. Next comes Spark core. Spark core is where it encompasses essential functionality of task scheduling, memory management, fault recovery, interacting with the storage systems, contains the API. In other words, notice Spark core sits on top of cluster manager. Cluster manager is working with the hundreds and thousands of computers. So we say Cluster manager is hiding the complexity of how we work with hundreds and thousands of servers. We are not writing the code. What is Spark Core doing? Spark Core is sitting on top of cluster manager. It is hiding or it is abstracting the complexity of cluster manager. We don't write the code to work with cluster manager. We are using the Spark Core. Spark Core is hiding the complexity of writing the hiding the complexity of cluster managers. You don't even have to know what cluster manager you're using, and you can still work with Spark. So all these things are taken care of by the Spark Core. Then comes to the built-in libraries. The Spark SQL is where we will write SQL-like code. It is nothing but Hive on Hadoop, Hive on Spark. We write different kinds of SQL. It is called, again, in Hive, we call it as HQL. It works with JSON data, Parquet data, and other kinds of data sets. It can be mixed with data manipulation supported by RDDs. So again, you can write mix of SQL queries, guys. The complexities in understanding RDD. We'll try to get a quick understanding. That will be helpful for you in understanding some of the parts of the Scala's thing and so on, guys. Okay. Spark SQL replaces the older Shark. Okay, earlier it was called as Shark. Hive on Spark was referred as Shark. So now they're calling it as Spark SQL is what it is. So there is Spark SQL. Spark SQL works with any of the databases. It takes the data, it converts, it makes it look like structured data. And what do we do? We can write SQL commands. We don't have to write RDD, Spark code is what it is, guys. Okay, Spark streaming. Spark streaming is, it enables Spark to process data in real time as it is ingested. So what is real-time data, guys? The small records of data which comes in, whether they are weather related or stocks related, that is called Spark streaming. That is what is called real-time. So Spark streaming is a package which is specifically made to work with real-time data. Data can be ingested. Ingested means process of storing the data from anywhere. You can get the data from a database, maybe from Hadoop, big data lake, and things like that. Examples of real-time social media tweets. Twitter, Facebook, data is constantly coming in. They're tweeting that a product is good, a movie is good, and Facebook, they're discussing, hey, this is the good, this is the bad side of it, and things like that. That is called streaming data. Log files are generally created every few minutes to every few hours. Log files are generated. That is referred as streaming. And e-commerce payment transactions. Every few seconds, every 1 second they get hundreds and thousands of transactions, and they need to process and send them back. That is nothing but streaming data, guys. Okay, so Spark can work with petabytes of data. It can also work with small amounts of data. Gigabytes of data is also really very huge. I mean, there's some good number of rows and things like that, but Spark streaming supports both. Next, MLlib, a quick idea. This is the machine learning. This is the AI part of it. This is the deep learning part of it. Spark has a separate package called MLlib. And there are other additional libraries in Spark, which are also used for performing the AI stuff, the machine learning and the deep learning stuff and things like that, guys. Okay. So internally, they find the correlations in the data. They perform different kinds of statistical tests. Several machine learning algorithms are built into them. And with Spark, so again, Spark provides a package called MLlib. It is designed to efficiently scale across nodes. So in other words, the main advantage is where generally when we work with Python, the data is sitting on a single server, whether you perform a machine learning algorithm or other kinds of processing. When your data sits on multiple computers or multiple servers, guys, these operations become extremely complex. That is what Spark is hiding from you. When we use Spark, Scala, Spark by Python, Spark is automatically taking care. These libraries or packages are hiding the complexities of these algorithms and allowing us to work with them easily. They're designed to efficiently scale across nodes, which is nothing but scalability. We discussed about that multiple times, guys. Okay. Then importing the data, model evaluation. These are the steps generally. So here is a package. They're a group of judges and they have the data. What is the problem? The problem is they don't know what to do with the data. That is where. So if you go back, the story is that in Egypt, Egyptians, hundreds and thousands of years back, they were maintaining some record books of, when to, in agriculture, when to put what kinds of crops and things like that. What is that? That is time series data. So if we have a group of judges, what do we do? The first step is have the data. And the second step is do something. What is it? This group of judges is nothing but a business. What is their final objective? They want to make profit from the data. What is that one? That's where the statistics, the machine learning algorithm comes in. And that's what is a package MLlib. So Spark has a package called MLlib, which is giving us all these models and algorithms, which will help us in making profit from the data. That's what the businesses are after, guys. Okay. Then GraphX, just like we discussed Gremlin in Azure Cloud Computing, Spark provides its own graph-like package or library, and it allows us to work with graph-like data. Again, just a high level touch of it, will not go too much into it. It's not required, but we need to have a quick idea about it, guys. That's for working. So here is graph-like data. What is it? Person 1 played PlayStation or maybe purchased PlayStation. He also purchased FPS games. Person 2 purchased Xbox and racing games. Person 3 performed Xbox and racing games. Now, here is a person 4 coming in. What is he doing? He is purchasing FPS games. What we would like to know is, we would like to know or predict his next step. What is it? That is exactly what graph-like data looks like. If person 4 comes in and he chooses FPS games, what is going to be his next step? Well, you make a prediction. What do you do? That's where we can use graph-like data. That's where the package GraphX or graph package comes to your rescue, guys. That's an example of a graph-like data. That's what I'm trying to convey. Okay, then again, a quick quick look at the Spark deployment modes. Spark can be deployed in 3 modes: local, standalone, and shared cluster. So local mode is when you download the Spark on your computer, you're just working on your laptop or computer, that is local mode. Standalone mode is again, you're not working with Hadoop or anything. You're just working with Spark and reading some files on your computer, and that is also standalone. But if you work with Spark and Hadoop or other big data analytics frameworks, that is referred as a shared cluster. What is happening is a cluster where you have a group of racks and servers. Not only Hadoop or other analytics frameworks are installed, on top of it, generally Spark is installed. So the cluster is being shared by Hadoop and Spark. Frameworks like Hadoop and Spark, so they call that as a shared cluster. All these things generally the administrator will take care of and deploy them, guys. Okay. So criteria for choosing a deploy mode: based on the resources, based on the processing, based on the technology, whether or not we want to use cloud services. These are the decisions that the architects and the admins will go ahead and make a decision what kind of cluster they need to use, is what it is. So here is local. Everything runs on one machine on your laptop. It is for learning Spark for small tasks and things like that. Not recommended for production. So if you really want to do some real world analytics and things like that, then this is just more of a small example we generally use in a Spark world, guys. Okay. Then standalone cluster, a separate cluster where only Spark is used, not any other frameworks. Jobs are distributed, work is being run, the memory, CPU and the memory is being utilized by Spark and alone, guys, as simple as that. Shared is where, again, we generally have Spark sitting on top of Hadoop, and then it is working with various frameworks such as Pig, Hive, and it could be another thing and so on, guys. Okay, so that's a quick look at Spark. Everybody with me, guys? Quick yes, please. The next step is we'll get a slightly in-depth look into Hadoop. Bring up the other one. There we go. Okay. Okay, guys, now we'll get into a little bit of Spark and Scala and try to understand some of the aspects of it. Okay, let's go ahead. So control, oops. So this one. Save it. Six. Six. Okay. Okay, guys, sharing the screen now. Okay. So there is Scala. Scala stands for scalable language, which means they're also trying to give us an indication Scala can be used to work with big data, small data, just like Python. So here is the godfather of Scala. His name is Martin Odisky, and recently introduced a multi-paradigm development language. So it's a slightly advanced way of writing code and things like that. That's what we'll try to understand. It enables concise and elegant code development. So it is concise. What we write in Scala in a few lines can be multiple lines of code in Java or maybe .NET. It is much more elegant. Again, it is much more short and sweet, neat, just like Python. It's an object-oriented language with functional programming features, means it is both object-oriented and functional, putting it in a simple way. You can not only use it as a functional programming language, you can also use it as a object-oriented language, guys, okay? Okay, so there it is, it stands for scalable language, that is what is Scala. So here is the godfather of Java, James Gosling. If I were to pick a language to use today other than Java, it would be Scala. That is the godfather of the Java, guys, okay? The guy who came up with Java is saying Scala would be the language that he would go to if he were to. And so here is a little bit about Scala. It runs on Java virtual machine. Internally, it maintains a small JVM. And so it is internally nothing but converting everything to Java. And it is taking care of all the Java stuff behind the scenes, but it is hiding all these things from us. This allows the use of Scala with Java or as an alternative to Java. So another name for Scala is better Java, is what they call this, okay? We can leverage existing Java libraries, means the libraries are nothing but the packages which are in Java can be used in Scala. Everybody with me, guys? Quick yes, please. Cool. Okay. It combines the strengths of functional and object-oriented. As I said, it can be used as a functional programming language. It can also be used as an object-oriented programming language, just like Python. Okay, so again, it is compatible with Java, which means it can work with Java. It is concise, much more. We write much more lower level of code. It is a high-level Java, just like Python is a high-level programming language. Scala is also a high-level programming language. Statically typed, we'll try to understand what that means. Python is dynamic, whereas Scala is static. We'll try to understand what is the difference, guys, okay? So some of the basic data types: byte, short, int, long. So byte is 8 bits and short is 16 and so on. A little bit of computer science concepts. Ideally, we don't worry how many bits or bytes are there. We are slightly at a high level. Float and double, they're nothing but the decimal values. Character is nothing but a single character, single textual data. And string is nothing but, again, our coffee cups. Boolean, true and false. And every data element is an object. So internally, just like Python, it has a lot of similarities with Python. We'll be discussing in the coming days. Everything is referred as an object in Scala also. Quick yes, please. Okay. So immutability. What is immutability? In in Python, we said strings are immutable. Here, the objects are, all the objects are immutable. What does that mean? So now in Python, if we want to say a equals to 1, if we want to create an object, we'll just say a equals to 1, right? Here we say val. Val means immutable. Immutable means you are indicating you don't want to change this one, which means if we say a equals to 1, you cannot modify it. These two will not work. Here you're trying to modify it to 2, here you're trying to addify. Why? That is what val is. Then we have var or var. Var means you're indicating, you're telling, or Scala is using var to tell, hey, this is an object which can be changed. So if you modify it to 2 or you add a 1 to it, then you can modify it. You can modify that object. That is a cup where you can change it. This is a cup where you cannot change it. That is val versus var. Val is immutable. In the sense, only you bind a value to a symbol defined as val. That binding can be changed. So short and sweet, you cannot change val. Val is immutable. Everybody with me, guys? Quick yes, please. I will try to run these operations in a bit and try to get a feel of that, guys. Okay. Next, the Scalar Ripple again will probably access the web shell. We'll have a Scala Ripple read, execute, process and loop. Read, execute. So I think something process or something like that is there, guys. But in other words, the Scala, you type in one line at one time. Notice here 2 times 3. The result is 6, and it's an integer object. What is it doing? When you perform a calculation 2 times 3, it is automatically identifying the data type, that it is an integer because it does not have any decimals. So that is a touch of dynamic. It is dynamically understanding the data type. That is a touch of dynamic. Generally, it is also static. It is not only static, it is also dynamic. And now, notice here, val a equals to 10. Val a equals to 10, it is saying a is 10 and its data type is integer. It is automatically understanding the data type. It is giving the data type as 10. Next, val b equals to a plus 1. So notice, val a equals to 10, no problem. But val b equals to a plus 1 means we are not changing a, but this is a new object. You can create a new object from an old object, but you cannot change that object. That's what that is. You cannot do a equals to a plus 1. Okay, so let's say Lavanya, anybody are accessing the Scala? Guys, anybody got into the labs, please? Can you let me know? We'll try to run a few labs and get a feel of Scala. Okay, let me make you the host, Lavanya. Can you unmute yourself, please?
Yes, Naveen.
Thank you. Making the co-host, you can share your screen. Let me come back here and pick user. Back to say back here. This is the people, and here's the documents. It's version 2. Factorial. Scala. Quick sort. Two-string. Okay. So we have here. It's 1524. One moment, please. Start with this one. Okay. Saving it. Right. Screen. Let's see what you have. Okay, you logged into Scala. So I'll send you one after one. You try to execute them. Chat window. Let's say, okay, start with a simple one. Okay, start with a simple one. Okay. As simple as a print line. Instead of print, we're using print line. Here's the next one. Okay. So now notice we're using val. So in other words, something different about Python is we always have to specify whether it is a val versus var. In Python, you don't need to give a val or a var here. Now change a equals to 2. Enter. It gives you an error. Try to change a equals to a plus 1. So notice it is saying, the error is saying reassignment. A equals to 1 is the first time you're creating, that is assignment. When you're trying to change it, you're trying to reassign it. One more time assign it. And it is not allowing it. That is because val means read only. Okay. Now let's say come back here. Not say var b equals to 1. So miss on this one. So here it is. Okay. Try to do this one. Okay. Try to do this one. Notice this is okay. Here we are not modifying a, but we're creating a totally different object. A1, and that is equal to a plus 1. That should be okay. This is assignment. This is not reassignment. Catching it, Lavanya?
Yes, Naveen.
Okay. Simple as that. Let's try the next one. Okay, try this one. Okay, now modify it to 2. No problem. Now modify, now add a 1 to it. You're assigning it. Say b equals to a plus 1. So notice no problem. Var means if you think our object is going to be changed. Now, why should we think whether our object will be changed or object will not be changed? Just most of the time in data, in the world of data, we don't change our existing objects. We always try to create a new object from a existing object. We always try to keep a copy of the original object. That is why most of the time we'll use val, not var. That is something to be aware of, guys. Okay, in a Scala world. And let's see what else we have. Okay, take a look at this simple one. Just type in 4.5. And enter. Notice it says a double. Double is nothing but a decimal data because there's a decimal there. Okay, now try this one. Okay, toString. Yeah, so in other words, now 4.toString, it is treating it as a string. Now say 4.toString with brackets Lavanya, no, 4.toString, and then at the end, like a function, put toString. So first put 4.toString. Enter.
Is string is capital. Okay.
So one moment, and let's say, now open bracket.
Open bracket.
Close the bracket.
Okay.
Here is enter. So here is a subtle difference between Python and Scala, guys. In Python, if you don't give the open bracket and a closed bracket, here the function of the method is not taking any arguments. If it is not taking any arguments also, you must give the open and the closed bracket in the world of Python. In Scala, if the function or the method is not taking any arguments, you can skip the open bracket and the closed bracket. Is a subtle difference between Python and Scala. Catching it, Lavanya?
Yes.
Everybody is doing okay, guys? Quick yes, please. Okay. So let's come back here. Okay, now let's try a few more basics here. Oops. Okay, run this, please. Okay, what do you think is happening here?
Converting 4.5 into integer.
As simple as that. So 4.5 is actually a double. We are converting it into an integer. Okay.
Why here it considered 4.5 as double instead of float?
Oh, double is 64-bit, float is 32-bit. So by default, it is taking slightly higher.
Okay.
64 because by default, if you want to explicitly convert it to float also, we can do that. We will see how to do that. Okay. If you need that level of optimization. So now here, let's see, good question. Okay, run the next one, please. So notice that one. Explain what is happening here, Lavanya.
Converting string into double.
Simple as that. So 4.5 is actually a string. We are converting it to double. This is called casting. Convert it to float. There it is. And notice on the left-hand side, it says RES6, RES5. That is nothing but the result object. You can read that as result. That is what it is internally. If you just type in RES6 there, just type in RES6. Enter. So notice internally Scala has created an object. It gave it a name because we did not give a name. So if you want, we can reuse that object. That's what it is about, guys. Okay. Next, let's say, okay. Try this, please. Okay, 4.2 double. So it becomes, it's actually an integer. We are converting it to a double. We're casting it to a double. We're converting a green tea to a ginger tea. That's what it is. Then just type in true. Okay, run it. Notice it gives an error. Why do you think it's giving an error? Can you take a guess? Pardon me. Sorry about that.
The variable true is not present.
Small t.
Small t. Okay.
Yeah. In Boolean, in Python, it is capital T and capital F. Type in a false also. So here, pardon me, it is taking the small t and the, it is case short and okay. Okay, let's try this one. Okay, run this one, please. Okay, can you explain what is going on, Lavanya?
Here x, y, z are integers and those are immutable, and assigning value 0 to those 3 objects.
Very good. Short and sweet, we are creating 3 objects at one time. If you want to do this in Python, what do you think we'll do, Lavanya?
Instead, we just simply remove the val.
And okay, let's try. Okay, here. Before I do this one, let me see if I need to explain this one. Okay, let me come back here. Let me explain a few concepts and go back to you. Okay, basic types and type inference. The basic data types are similar. The integer, the float, the string character and things like that. Similar to Python, it is a little bit more explicit here in saying it's a byte and a short. So again, val x equal to 1, x is immutable, and value of 1, the value is 1. Notice x equal to 2 gives you an error. It is forcing you either to say a val or a var. It is asking you to either tell, Scala is forcing you to tell if it is immutable or mutable. Okay, Scala uses the type inference. Once you say x equal to 1, it is automatically inferring the type. That is referred as type inference. It is automatically, the compiler is automatically understanding that this is an integer object or a float or a double. That is referred as type inference. The keywords val and var begin with a lowercase. In other words, that's case sensitive. You give a capital V, they won't work. Okay, guys, let's move to the next one. Okay, here is a function def add, again, same as Python. Now, here is a small catch which is coming in, but before we go this far, let me see, come back here. Okay. Bring this back here. Oops. Functions, lazy evaluation, scalars, arrays, buffers, maps, lists, higher order functions. Okay. Basic types. Okay. So bringing the function back up, sharing the screen. Okay, just like Python, we start with def, add A and B, but notice we are giving the data type. The catch with Scala is, unlike Python, in Python, you don't have to give this data type. The argument A and B are integer and integer, you don't have to give it. Okay, and notice the colon int. This is when we execute this function add, what is the return data type? Just like Java and .NET. So that is what is called static. It is statically typed language. You have to explicitly tell that this is integer, and what you're expecting is also integer. That is called statically typed language. So what we are doing is inside the function, we're writing in one line, equals to a plus b. What is this? This is going to be returned. We'll execute this step by step in a moment here, but just quick explanation. So notice, this is function, we defined it here. Now we are saying, oh, okay. Int a equals to a plus b. Okay, val m is int. Now notice this, guys, another complexity, another something different. When we say val m, we are also giving the data type. We are saying, hey, val m is integer, expect an integer. So whatever is being returned here it is again assigned here, and it is integer data type. So what is that? That's an additional step that we need to manually. We need to give the data types of the arguments. We need to tell what type is that function is returning. And at the time we're saying it, we're also giving the data type. We use the type declaration in Scala is statically typed language. We can define add to be a function which accepts 2 parameters of the type int and returns a value of type int. Okay, it is taking 2 arguments int and returning an argument. M is defined as a variable of type int. This is how these data types is what is additional compared to Python. Otherwise, it is similar to Python, guys. Okay. Okay. So again, the same thing. There is no explicit return. The value of the last expression in the body is assumed, is automatically returned. So a plus 1, you are taking an argument A, Then we are adding a 1, subtracting 2, multiplying 3. Whatever is the last one is automatically written. We don't say return. In Python, we say return. Otherwise, it will just execute. Another difference. So value p int function of 10. So this is going to get, let us say we passed in, let's say 2. 2 times 3 is going to be 6. P is going to be 6. That's what we'll do. So in other words, something to be kept in mind is in Scala, we don't explicitly say return. Everybody with me, guys? Quick yes, please. Catching it? Okay. And again, type inference. Add AB. It is return. So Scala is going to return AB. Now, what is it? We didn't give any type. So here, M will be, if you give 1 into that will be an integer. We have not specified the return type. So Scala infers, if you don't give it, it is automatically inferring the type. So you can force it. You can also not give anything. It will, you can let Scala decide it here. Then type inference, while M equals to add 1. So notice, let's see what is happening here. Add AB. So what is this? This is a Python function. In Python, you just say add AB. You don't give the data type. This will not work. Scala does not infer type of the function parameters or the arguments. Unlike Haskell, ML, or Python, Scala is said to be local flow-based type. Okay, we don't need to go into the Haskell aspects of it, but more precisely, that is unlike Python, you have to give the data types of the arguments. Quick yes, please. Okay, next let's see expression-oriented programming. Well, I equals to 3. Then we say, well, P is equal to if I greater than 0, minus 1, else minus 2. Well, Q if true. So I, P, Q are 3 variables. We're printing P and Q. Unlike languages like C, Java, almost everything in Scala is an expression. That is something which returns a value. So everything is written a value. If this conditional value is to true, minus 1 will be returned. Otherwise, minus 2 will be returned. If true is true, so always hello will be returned. Rather than programming with statements, we program with expressions. So these are referred as expressions. The statements of lines are referred as expressions, guys. Okay. Then let's say case automatically returns the value of the expression. So if you give an error message of 2, it goes 2 is here, 2 matches 2. So this is returned. Whatever is getting executed, it is not the last one which is getting returned. So error code match. Error code is 2. It is matching 2. So this is getting returned. And again, we'll try to execute it, but let me quickly go here, guys. Okay, so let me come back here. Share your screen, Lavanya.
Yes.
Send chat window. Okay, here we go. Try this, please. Okay, what do you think is KV, Lavanya?
KV are the objects and we are assigning the value 3, 5 to them.
What kind of an object does it look like?
Integer.
It's a tuple object.
Yeah, tuple.
Okay. Normal brackets is tuple. If it is square bracket?
List.
Good. Say next one, let's say again one more time. Take a look at this. Okay, run this one. So let's say, what do you think is the problem here?
Comma. The separation between the values.
Can you try to fix that if you think that is a problem? That's a tough question.
Can we separate them with the semicolon?
Okay, run that. So semicolon, put 0, semicolon 1, semicolon 2. Okay, I'll be surprised if that works. Put a 2 replace the commas with semicolon. After 2 also put a semicolon.
Okay.
Put a semicolon after 2. Okay. So in other words, again, what it means is we can initialize, we can create multiple objects to one value. In other words, bring up that statement, just put a 0, remove the 1 and 2. Remove the comma. Now run it. Notice multiple objects are created, you can put the same value. But now bring that up and do 0, 1. This will not work. If you do 0, 1, 2 also, it will not work.
Yes.
Okay, just do it one more time.
This one?
Okay, so the reason, what it means is, you can put the same object in all these objects at once. You cannot create multiple objects with multiple values. You can create multiple objects with the same value. Everybody catching that, guys? Quick yes, please.
If we want to create like that, in that case, we have to use tuple or list, right?
Good one. Okay, give it a try. Good suggestion, Rahul. Okay, so just type in X. Okay, so now X is becoming the tuple. How do you get X equal to 0?
Naveen?
We want X to be 0, Y to be 1, and Z to be 2, not a tuple. Here X is a tuple. Y will also be a tuple. Execute Y. Notice it will be a tuple. But we don't want that like that. I want X to be 0, Y to be 1, and 2 to be Z to be 2. In other words, there is a small and subtle change that you need to make in the syntax that you used. Good one. So, okay. Okay, what is the change you need to make, Lavanya? You're close, just away from one step.
Let me try to do this way.
Okay. Good one. Catching it?
Yeah.
Everybody okay with that, guys? Quick yes, please. So here we're creating multiple objects XYZ, but how we're creating, we're using the tuple.
Let me try with list.
Okay.
Illegal start of a simple pattern.
So yeah, list we'll see in a moment.
Okay.
And let's see what else. Okay. So here is a simple function. Okay, try the function. Okay, so yeah. So now just type in add 1, 2. Okay, so there it is. We're now getting it. So that's like a function. Let's say now take a look at this one. Back to chat here. Okay, run this one. Okay, repeat add of 1, 2. Okay, there's a subtle difference between both the functions. What is it?
Here the object B is double and the output is also double.
Good. Okay, so the return type is double. Everybody catching it, guys? Quick yes, please. Okay. Okay, let's see. Try this one. Can you take a guess what is the problem here?
We are trying to get the output in string.
Okay, so can you take a guess how we fix this, Lavanya? It's probably a medium complex one for someone like you, but for others it might be a tough one.
Is Scala has str of?
Okay, what's the shortcut for that?
String of A plus B.
How do you?
I don't know will this work or not. This will be the keyword right here. It's not okay. Oh. Replace.
Okay, good luck.
Oh, okay.
Excellent. Try it now. Cool. So what are we getting? We're getting 12. You passed in 1 and 2. Yeah. 1, 2 is 12. Okay. So that's a good one. Try this one also.
Inputs are string and output is also string.
Let's see. Did you get that? Okay. Run it now. I haven't tried it. I'm just seeing if it's going to.
Oh, string.
What's the problem? I think it looks good to me.
Yeah.
Cool.
Why
Okay.
single quotes don't work?
Good. Single quotes are not accepted.
Okay.
So Python is probably a little bit more flexible there. But let's say what else we have had. Okay, let's say try this one down here. No, I think we should change the function. Try these two. So new again. Try these two.
Wow. Okay. Now, the whole means for method and
Let's do this, Lavanya. Let's take a lunch break and let's come back and fix this one. You keep trying if you have a minute, and we'll take a break and come back, okay?
okay.
Everybody okay with that, guys? Quickest, please. We'll regroup by 2:10 to 15. Thank you. Okay, guys, are you back? Great, thank you, guys. Sorry about the delay. So let's get started, guys. Lavanya, can you share your screen, please?
Yes, now.
Thank you. I think you're in the web shell. Okay. So how did you fix it, Lavanya?
Yeah, I tried different ways. Here, I tried to convert the double B into int and got the output. And another case is here, this one. I directly changed the data type of M to double. And here, I changed the output to integer.
Excellent. Good job. Okay, so let's see. Now I have a slightly deformed. Let's see if you're able to execute this one. Putting it in the chat window. There you go. Try this. I don't know if it'll allow the multi-line statements, but just give it a try. What you do is after a+1, put a semicolon, just to indicate a new line. Let's see if it'll take it.
Here,
Similarly, after a-2 also. Okay, press enter. Now pass in function of, let's say, 1. Okay, can you explain what is going on, Lavanya?
it executed this expression, last expression, 1 into 3.
Did it execute it?
Yeah, return. Oh, it returned the last
It's
expression
not
of,
just executing it, it is returning it, to be more precise, okay?
yeah.
Now let's say I want to put that result into new object. How will you do that?
Yes. Is there any other way?
Okay, that's it. You're missing the val part of it, Lavanya.
Val.
You were just saying m equals to, right?
Yeah.
That's what.
Is val must?
Yeah, val is must.
Okay.
Okay, and let's see. Okay, let's see. Try another one here. Run this, please. Okay. Volume equals to 1. And so what is different here, Lavanya?
Along with return, here we are printing the first and second expression.
So first we are executing, then we are returning. That is the only difference. Okay.
Yeah.
Pardon me. Okay. Okay. Let's see. Can you write a function which will calculate the area of a circle, Lavanya? Others can give a hint to Lavanya, guys.
Can we use brackets here? That is not a member of W. Naveen,
Yeah.
for for powering, what we use in Scala?
Power.
Pi r square. R square.
Oh, just do R. R multiplied by R.
Just RR. This one?
Yeah.
Oh.
Very good. But what's happening? Oh, 3.14. Okay. Good. But why did you name it circle?
I just given function name circle.
Okay, good one there. Better name is area of the circle. Okay.
Area of the circle.
Or
Yeah.
just you can say area.
Okay. For instead of this one in Python, what we use in Scala?
Pardon me? What is that? Oh,
For
exponential. Huh?
yeah, exponential one.
Exactly, I don't remember, Lavanya, but I think for now we're just using. I think we should be able to have a utility package or something like that. Somewhere we have.
Okay.
Okay. So let's see. Okay, here's another one. Try this one, Lavanya. Okay. So here, what is different? What do you think is different here?
We did not mention any object like A here. Direct out.
Okay, okay. Anything else from a syntax point of view? It's slightly different from Python.
syntax
Or
one.
I will put it like this, it is slightly similar to Python here.
By default, it takes the
Yes.
data type which has more bits.
The data type which has more. Oh.
Size.
Okay. Looks like you're already answering it. Okay, so in other words, more precisely, you did not specify the return data type.
Okay.
Okay. As simple as that. Okay, let's say, okay, run the one that I sent you. Let's see what we're doing here. Okay.
Here we are trying to assign the double value to integer.
So how do you fix it?
Simply we can remove it or mention it as double.
No.
What happened?
I want the return type
Return
to be integer, not double.
integer. Okay. String. We can give directly here or while calling. We can put area of 2.2 integer.
Good one. Yeah, good job. And we can come back here. Okay, so give me one moment here. I'm trying to find something. Okay, so cloud storage. Okay. Okay, we'll jump back to a little bit of Azure. Lavanya, I'm going to share my screen here. Sharing the screen. Okay. See, let me choose somebody else here. Suresh, are you there, buddy? Suresh. Okay, I think Sai Srirup, are you there? I think you were the one who said who didn't complete the. Sai Srirup, are you there?
Hi, sir.
Okay. Can you come online, show yourself, please? Let me share the screen here. Okay, sharing the screen. And let's say, can you read this out and try to answer this one?
The practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. Yes, sir. True.
But what is it called?
Cloud server.
Pardon me?
Cloud, sir.
Oh, cloud computing.
Cloud computing, yes, sir.
Okay, let's say. Okay, read out, please.
You own the servers, you hire the IT people, you pay or rent the real estate, you take all the risk.
What does it remind you of?
Is this a feature of cloud computing?
Okay. How about any help for Sai Srirupa, guys? What is this one? What do you think is happening here? Can anybody give hints to Sai Srirupa?
Private cloud.
It is on-premise.
Okay, sir.
Private. What is meaning of on-premise, Sai Srirupa?
Is this a network that Azure should connect?
On-premise means this is in your own company. In our own company, we own the servers, we hire the IT people, we pay the rent and the real estate. We take all the risk, right?
Okay, sir.
Have you been reading some of the questions and things like that?
Yes, sir, little bit.
Little bit kaadu, koncham. You have to study more, okay?
Okay, sir.
Okay.
Someone else owns the servers, someone else hires the IT people, someone else pays or rents the real estate. You are responsible for your configuring cloud server and code. Someone else take care of the rest. Oh, no idea, sir.
These are the basic questions, Srirupa. Repu certification petti, if you're not able to answer the basic questions, etla? You understand, Srirupa, what I'm saying?
Yes, sir.
You have to take it a little bit more seriously. If you are not able to answer slightly tough questions, it's okay. But simple questions, if you're not even able to attempt, then you should study more, okay?
Okay, sir.
Okay, try this.
Connection dedicated to single business and the single website.
Please read it.
One physical machine dedicated to single business runs a single website. Very expensive, high maintenance, high security.
It's a slightly tough question, but try to answer it. Can anybody give a hint to Srirupa, guys? Anybody else wants to give a try? Very good. So that's a dedicated host, dedicated server. And Srirupa, do you think you can explain what is a dedicated server mean?
There is only one machine to host a single business or other functions.
Where is that machine?
On network, it runs on a network or something web apps.
On the cloud.
Sir, on network.
On the cloud, we are taking a server and only we will be using, no, anybody else will not be using. Okay. Try this, please.
One physical machine dedicated to a single business. The physical machine is virtualized into submissions, run multiple web apps on sites.
This is a tough one. I didn't expect you to answer, but give me a try.
Multiple host.
Can you explain this? What this is saying?
There is one mission to host a business, but in that mission there are submissions.
What does it mean by submissions?
In one mission, there are multiple missions inside it to run the applications.
So submissions means virtual machines, okay?
Virtual mission.
Okay, so that is called virtual private server. It's a slightly tough one, okay? Let's see, try to read this and answer this.
One physical mission shared by 100 of business relies on most tenants under utilizing their resources.
This is also a tough one. I don't expect you to answer, but just give a friendly try.
It's almost.
Okay, that's a tough one. That's called shared hosting.
Okay, sir.
Do you have any idea why shared hosting is very cheap?
There is only one mission and it's shared by hundreds of people.
Okay, good answer, as simple as that. Okay, try to answer this.
Multiple physical missions that act as one system. The system is abstracted into multiple cloud servers. Flexible, scalable, secure, cost-effective, and high configurable. Cloud services.
Okay, let's see. Can anybody give a hint to Srirupa? Okay, that is cloud hosting. Okay. Pardon me. sharing screen again. Yeah, try to read this and answer this. Choose right one.
Relational databases uses dash to enforce the relationship between the different tables. Columns keys,
Why keys?
by using keys, we get the values.
Can you give an example of key?
Key.
Can anybody help Srirupa guys? Example, Lavanya? Do you know what is the difference between primary key and foreign key, Srirupa?
Primary key is used in one table, whereas foreign keys to get the values between two tables. Primary key is also a unique key.
What is foreign key?
Foreign key, it can be used between two tables, two different tables.
Okay. Okay. Read index, read and read, choose right answer.
An ideal process requires data, a target data stores powerful enough to transform data. Data is fully processed before being loaded to the target database. A matching schema in the data source and the data target. The data target to be a relational database. Extract or transform. The data is fully processed before being loaded to the target database.
Why do you say that?
Here ETL means extract or transform and load. So
What is the meaning of fully processing?
we can process the data before it's load.
Processing means that's where you are making some changes. The changes can be transformations also, okay? Then you're
Okay.
loading. So first transforming, then loading. So that's why ETL is fully processing, then loading the data. Do you know what is the meaning of schema?
Schema. It's a logical view of table.
Logical view of the table. Logical view of the table. Okay. Guys, any hints? What is the schema? Okay. How about others, guys? Others are not answering, only Lavanya is answering. Please feel free to answer, guys. Okay, read the next one.
Which type of non-relational data store supports a flexible schema, stores data as JSON files, and stores all the data for an entity in the same document? Column, graph, document, time series. Document,
And why do you say it?
it is a non-relational data type.
Okay. Okay.
Azure Data Studio is supported on which platforms? Windows, Mac OS, and Linux.
Good answer. Give me one moment. Okay. Continue. Read and answer, please.
Which among the following statement is true with respect to the Azure SQL database?
Read, please. Read all the answers.
Okay. You can use existing Microsoft SQL Server licenses to reduce the cost of Azure SQL database. None of the above. You need a Microsoft 365 subscription to create an Azure SQL database. You must apply patches to the Azure SQL databases regularly. With respect to Azure SQL database. You can use existing Microsoft SQL Server. Option A.
Good answer.
Your company needs to implement a relational database in Azure. The solution must minimize ongoing maintenance. Which Azure service should you use? Azure SQL database installed on VM, SQL Server on Azure Virtual Machines, Azure Cosmos DB, Azure SQL Database, Azure HD site. Azure SQL Database.
And why, Srirupa?
It's a relational database, sir.
Okay. Do you know what is Azure HD inside?
No, sir, I'm not remember right now.
Okay. HD stands for Hadoop. Okay.
Okay.
So what is Hadoop inside? What do you think it is?
We can use Azure in Hadoop.
It's Hadoop on Azure, as simple as that. Okay. Okay. Read the next one.
Statement is used to include another column in the table schema in a relational database. Insert, sir.
Why do you say it's insert?
We want to include another column, so just insert.
You want to include another column. Okay. So it's actually no change needed here. Alter is a DD. Is it a DDL? Yeah, it's a DDL. Is alter a DDL, guys? Do any of you recall? Yeah, alter is a DDL. It's not a DML. Insert, update, delete are the rows. When you're making any change to a table that is a DDL, here inserting another column means alter statement is used to include another column means it is including a column in a table. So here insert is actually inserting a row in a table is what is the insert here. So ideally the answer would be no change needed. Okay, Srirupa?
Okay, sir.
Okay.
Azure Synapse Analytics is used to perform very complex queries and aggregations. Create dashboards from tabular data. A large number of users to query analytics data, no change needed. Enable large number of users to query analytics data.
Enable large number of users. Okay, here, no change is needed. Actually, in Azure Synapse Analytics is used to perform very complex queries and aggregations.
Okay.
Do you know what is meaning of aggregation, Sri Rupa?
It means app mapping.
Okay. Okay, let's see. Try this one.
Which API of Cosmos DB can be used to work with column-based data? Cassandra.
Why Cassandra?
It's Cassandra is based on column.
Based on columns, huh?
It's
Column families.
column family.
Okay. What is MongoDB based on?
MongoDB for documents.
Okay. What is an example of document? What kind of data is it?
Unstructured data.
Is it unstructured?
Structured data.
Semi-structured data.
Semi-structured.
What is granular?
No, sir, no idea.
Graph-like data. Okay.
Okay, sir.
What about table?
It's rows and column.
More precisely here, that is a key value database is what it is. Okay, next one.
Which activities can be performed entirely by using the Microsoft Power BI service? Select the correct option. Data acquisition and preparation, data modeling, report sharing and distribution, report and dashboard creation. Report sharing and distribution, report and dashboard creation.
Okay. So, okay. Can you take a guess what is right order here?
Resource group, queue storage, file storage, table storage. Storage account. Storage account, queue storage, resource group, file storage.
I think it should be subscription will have resource groups. Under resource group, it will have storage account. Under storage account, it will have file storage. So if you're looking at the screen, resource group will come here. Under resource group, there is a storage
account.
Under storage account, there is a file storage. These two are not here. Okay.
Okay.
Okay. Let's see. Say yes or no. Which one is yes versus which one?
Azure Cosmos table API supports multiple replicas. Azure Cosmos table. Right. Because both are S.
And where do you see that? It's a tough question. Both are yes is true. Okay. Multiple reads and multiple write regions. What kind of database is Azure Cosmos DB?
No SQL database.
What does NoSQL stand for?
Not only SQL.
Good answer. Not only SQL and or no non-relational database is what it is. Okay.
Which type of Azure storage should you use?
Oops. What's happening here? I think something is missing here. Okay, let's see. Take up this one.
Azure Resource Manager templates use XML format. No chain needed.
Why? Any help, guys? Please feel free to help Srirupa. It is JSON. What does JSON stand for, Srirupa?
JavaScript object notation.
Okay. Next one.
Azure Data Factory component provides the complete environment for Sir, I'm not able to see complete question. What is the last one?
Oh, pipeline.
Question, sir, in question.
Oh, one moment. Okay.
Which Azure Data Factory component provides the compute environment for activities. Pipeline, sir.
Compute environment, it's going to be an integration runtime. Okay. Okay.
Okay, sir.
Okay.
You need to store data in Azure Blob Storage for 7 years to meet your company's compliance requirements. The original time of the data is unimportant. The solution must minimize the storage. Achieve
And answer also, Srirupa, so that others can listen and follow you.
what storage type should use? Achieve, sir.
Archive. Okay. Well,
Archive.
what are you saying, archive?
Sir?
What do you say, archive?
Because here hot means frequent data store, cool means infrequent. So
Very good. Okay. Next one.
which of the following Azure services can be used to provision Apache Spark clusters? Spark clusters. Azure Databricks, Azure Log Analytics.
Azure Databricks and Azure HD Insight.
Okay.
Databricks is Spark, HD Insight is Hadoop. On top of it, we can install Spark, okay?
Okay.
Okay. Let's see. Start with dynamic data masking. What is dynamic data masking?
Dynamic data test, including database log without requiring changes to the application. Use it to protect sensitive data by limiting access to the data at rest, in movement, and in use to client applications that have appropriate access to keys. Use it to encrypt data in motion between the database server and clients using certificate-based encryption. Use it to limit exposure of sensitive data to non-privileged users by designating how much of the sensitive data can be revealed. Data masking, use it to explore sensitive data, non-reliable users. Defining how much of the sensitive data can be revealed. Applications that have access to the keys. Use it to encrypt data in motion between database server and clients using certificate-based encryption.
Data in motion. Okay. Okay. Try. Let's say try with always encrypted. Which one do you think is always encrypted means?
Always encrypted. Use it to encrypt data at rest, including database logs, backups.
So one option is remote. That is always encrypted. Now try to match either one of them. Dynamic data masking, transparent data encryption, transport layer security to the remaining three. Start with whichever seems to be similar to you, familiar to you.
Access to the data at rest. Client application that have appropriate access to the keys.
Okay, let's do this, Sripa. Let's take a short 5-minute break. Okay, Srirup, are you back?
Yes, sir.
What do you think is dynamic data masking?
Last option, sir.
What do you think is transparent data encryption?
Option B, sir. Use it to protect sensitive data.
And what about transport layer security?
Oh, C, sir.
Okay.
You have data stored in ADLS in text format. You need to load the data in Azure Synapse Analytics in a table in one of the database, which are the two components that you should define in order to use Polybase. Data stored. We have data stored in ADLS in text format.
Do you know what is Polybase, Srirupa?
Yes.
You know what is Polybase? Yes or no?
Oh, no, sir.
So Polybase is used for transferring data from any external sources to SQL Server database, okay?
Okay.
So we just specify the external source and the format. It's okay, we don't compromise that one. Okay, choose all the yes or no.
Does normalization involve eliminating relationship between database table? Does normalizing a database reduce the data redundancy? Does normalization improve the data integrity? Option 2 and 3 are yes, sir. First option is no.
Good answer. Okay.
Which of the following are examples of unstructured data? Blob storage. Blob storage, CSV files, and log files.
Good. Can you answer?
Descriptive. Why did sales increase last month? Sir, why did sales increase last month is diagnostic analytics. How do I allocate my budget to buy different inventory items? The rise of COVID-19 cases in a country. Last one is cognitive analytics.
How do I allocate my budget? Huh?
Yes, sir.
Yeah.
Sorry, sir. Sorry about that.
Okay.
Rise of COVID-19 cases in a country. Descriptive, sir.
The rise of COVID-19 is predictive analytics. How do I allocate my budget is you're taking an action or decision that is prescriptive analytics. Okay.
Okay, sir.
Okay.
Which of the following Azure database would be considered as infrastructure as a service. Cosmos DB, SQL Server in a VM, Azure SQL database, SQL managed instance. SQL database. SQL managed. Azure SQL database.
Azure SQL is platform.
SQL Server in a VM.
Yeah. Okay, read please.
You have the following JSON document.
What is customer? What is address? What is social media? Here is a hint.
Customer, let's see. Customer is a root object, sir.
Okay.
Address is a nested object.
Okay.
Social media is a list object.
It's a nested array.
Nested array.
Good answer. Okay.
Which of the following are common characteristics of a relational database? Data stored in a CSV files in a blob storage account. Stored in JSON format. Database prevents the deletion of a parent record if a child record exists. Foreign keys. Data is stored in a table format and rows and columns. Foreign keys. Stored in data is stored in a table format.
Okay.
Foreign keys. Option C, D, sir.
Very good. Okay. Choose yes or no.
Azure SQL database includes fully managed backup service. Azure SQL database built in high availability. Azure SQL database use Azure Advanced Threat Protection. It uses Azure Advanced Threat Protection. First two are yes, last one is no.
Say. Includes. Do you know what is managed service mean?
It's managed by Azure, sir. Fully managed.
Good. So your answer is first one is yes, sir.
Yes, sir.
And second one?
Yes.
Third
Last one? No, I think.
Azure Advanced Threat Protection. Tough question. I'm thinking the answer is yes, Srirupa, but I also need to verify that. But that's okay. I'll see if I can get back to you. Okay, choose next one.
Which is used to access data stored in Azure storage account. Stored in Azure account. Azure Data Studio, Azure Storage Explorer, SQL Server Data Tools, SQL Server Management Studio. Azure Data Studio.
It is Storage Explorer, okay?
Okay.
Studio is used for accessing the databases. And SQL Server Data Tools and SQL Server Management Studio is purely for SQL Server. Okay.
Sir, first encryption is first one. Authentication is second one. Firewall is third one, sir.
Good one. Okay.
Which of the following is a characteristic of non-relational database? Non-relational database contain tables. Non-relational database are either schema-free or have relaxed schemas. Non-relational database require you to use data normalization techniques to reduce the data duplication. Second option, sir.
Non-relational databases are schema-free, have relaxed columns, okay. Contain tables, okay. Non-relational database require you to, okay, good. Second one is right, B is right. Okay, let's see what we have, okay. Read the question.
Expenses table. From the expense table above, your manager asked you to write a SQL query to get the below results. Date, amount. Select a date from table where amount equal to sum of amount.
Okay, good answer. I'll give you a hint here now. Okay, let's see if you can choose the right one.
Expense table amount. Select expense type amount from expenses group by data. Select expense type sum amount as amount. Option C, sir.
Good answer. Now, option C. You want this kind of output.
Okay. Sir, once show me the options. Okay, option B, sir. Select date.
Okay, map it.
Let object whose content is defined by a query. Next one is table data object is that helps improve the data retrieval time. Sir, first one is table. Second one is index. A third one is that object that holds the data. Index. Database object that holds. So table is last one.
Okay.
A database object that holds the data. Second one is index. First one is view.
Good one. Okay. Okay, tough one.
Match the types of activities to the appropriate Azure Data Factory activities. Match the types of Control means until. Data movement means copy. Data transformation, mapping the data flow.
Answer, I think, Srirupa. Okay.
A relational database must be used when large images and views. A dynamic schema is required. Data will be stored as key value pairs. Strong consistency guarantees are required. Data will be stored as key and value pairs.
Why?
We store data in the form of table.
Key and value means we just have a key and a value, right? One key and one value, right?
Yes, sir.
But database has many columns, isn't it? Dynamic schema required. Strong consistency guarantees are required. Okay.
Okay.
Strong consistency means your data is consistent and does not give you wrong data
Okay.
and things like that. This is earlier. Okay.
Which of the following columns would make a good primary key to a relational database? Make a good primary key. ID is employee ID.
Why?
ID is unique, sir. Every
Good answer. Okay.
okay. Which of the following tools can be used in macOS to access data stored in Azure SQL database? macOS. Azure Storage Explorer.
Why do you think so?
By using this, we access the data in Azure, so that's why.
Storage Explorer is used for accessing storage data.
Yes, sir.
Asking for Azure SQL data.
SQL Server Management Studio. Yeah. Option B.
Option A, Azure Data Studio. SQL Server Management Studio is only for Windows. Okay.
Your manager assign you a task to find out a way to extract employee names from thousands of PDFs. Descriptive.
Why?
Or descriptive means we can perform actions based on past data. So
let's say you're extracting employee names from thousands of PDFs. Any hint for Srirupa, guys?
option B. Descriptive analysis.
Okay.
Option B, sir.
Option B, option D should be cognitive analytics. I'm surprised nobody helped there. Okay. Okay.
An Excel file contains user data saved in blob storage. Account is an example of which type?
Sorry about that. 1 moment, please. Here we go. Here we go.
An Excel file contains user data saved in a blob storage account is an example of what type of data? Batch data.
Why do you say it is batch?
Streaming data is a real time.
Good answer. Okay.
Batch workloads. Collect and process data at most daily. Collect data and then process when condition is met. Process data in a memory row by row. Process the data in real time. Collect data and then process when condition is met. Option B, sir.
Okay. What was your answer?
Option B.
Okay. Good one. Okay.
Which are the services in Azure that can be used to ingest the data? Ingest the data. IT Hub, Synapse Analytics, Azure Databricks, Event Hub, Stream Analytics Job. Azure Databricks.
Do you know what is the meaning of ingesting the data, Sri Rupa?
I mean, collecting the data. That means source.
Good answer. Okay. So why do you think it's Databricks?
Oh, no, sir, I just give a thought.
What do you think is IoT Hub? IoT Hub, Internet. IoT stands for Internet of Things. You know that?
Sir, internal?
Internet of Things.
Ah, okay.
Okay, Hub is the place where you collect the data.
Okay, okay, sir.
Do you know what is Synapse Analytics? Azure Synapse Analytics.
It's end-to-end solution.
Very good. It's used for big data analytics on structured data.
Okay.
Event Hub means, again, another hub or a storage which is storing all the events. So it should be IoT Hub and Event Hub, okay?
Okay.
Databricks is used for processing the data.
Okay.
Stream Analytics job, again, that is for processing the stream data.
A wind turbine that sends 100 sensors recording per second is an example of a streaming workload. Your credit card bills that generate every end of month is an example of batch data. Salary credited to your account on the last day of every month is an example of batch workload. End of the month. Wind turbine that sends 100 sensors recording per second. First one is true, sir. End of the month is second one is false. Last day of every month, batch work. Third one is S.
Why do you say second one is false?
Credit card is we use in real time, sir, at the time.
Okay, more precisely, a credit card statement is what it is. Credit card statement, you use it in real time?
Sir?
Do you use a credit card statement in real time?
No.
Credit card statements, yes. We use them, we do not use them in real time. We use them in batch processing.
Okay, okay.
Okay, and salary credited statement to your account on the last day of every month. What did you say? True or false?
True, sir.
Yeah, it is. I think the actual answer they're giving it as true. So we'll take it as true. Okay. Okay.
By default, each Azure SQL database is protected by.
Oops, sorry. So.
Sir, before question for the second credit card bills, is it yes or no? I think yes.
Credit card bill or second one, huh?
The statement given like generated at the end of the month.
Yeah, that's batch, right?
That is true, right?
Yeah,
Not
that's
false.
true.
Okay.
Okay.
Which SQL database is protected by second level firewall, NSG, Azure firewall. Azure firewall.
Good.
You have a quality assurance application that reads our data from a data warehouse. Which type of processing does the application use? Students application that reads data from a data warehouse. Online transaction processing, batch processing, stream.
So remind me tomorrow, buddy.
Online analytical processing.
Online analytical processing, did you say?
Yes, sir.
Yeah.
You have an Azure Cosmos DB account that uses the core API. Which setting can you configure at the container level? Core API. Select the correct option.
That's a tough question.
Read region and partition key.
That should be the throughput. Okay. The partition key is at a table level. The region is a very high level. And the throughput is SQL API. The throughput is one of them. Container level. Is done at container level, I think. A and D, the API. Yeah. The SQL API, you can use SQL API, document-based API, and things like that. So it should be A and D, okay?
Okay.
It's like I have one more here. Okay, let's see. Share this. Okay.
Which type of database workload is the day-to-day operation of your business? Database workload. Data warehouse.
Why data warehouse? It
We
is
use data in everyday.
OLTP, okay? Online transaction processing. Data warehouse and OLAP is for analytics and things like that. They're asking for day-to-day business. Which database? Database is OLTP again, okay?
Okay.
Okay, let's give me a moment here. Bring this up. See. Moment is. Okay. Bring the stream one more time. Let's scroll up here. Okay. Let's see. Okay, read this one.
A cloud provider can have hundreds of cloud servers that are grouped various types of servers. The four most common types of cloud services for infrastructure as a service would be.
So basically, I have given you 4 hints, Sri Rupa. Do these things remind you of anything? Let's say here is one hint.
A virtual computer that can run application, programs, and code. We need virtual machine, database, hard drive, and cloud network.
Okay. So what is this one? What is compute?
Sorry about that. Imagine having a virtual machine.
That is a compute. What is having a virtual hard drive that can store files mean?
Virtual hard drive can store files. We need to store the files in cloud.
That is storage.
Ah.
Okay, what does this one mean?
Imagine having a virtual network, being able to find internet connection and network as a cloud network.
Very good. What does this one mean?
Database or SQL. Imagine a virtual database for.
Okay.
Okay.
What do you think is Azure mean?
Azure literally means
Do you have any idea what is CSP mean?
oh no sir, I don't remember.
Cloud service provider. Azure means bright blue color of the cloudless sky. Okay.
Bright blue color of the cloud service providers can be initialized. Cloud server. Okay sir.
Okay. What does that mean?
You pay for what you consume, no upfront cost, pay as you go, thousands of customers sharing the cost of the resources. We just pay for what we use. The cost of the resources. Pay as you go. Serverless. Cost effective.
So far. Okay. Let's see. What do you think this means?
Launch workloads anywhere in the world. Just choose a region. Oh. Public cloud.
Global footprint. Okay.
Okay.
do you think that means?
Cloud provider take care of physical security. Cloud services can buy secure by default, or you have the ability to configure access down to granular level. Cloud provider takes care of physical security. Infrastructure.
That is secure. Why is secure important, Sri Rupa?
We have to secure our data.
Good, as simple as that. In other words, the data on the cloud is secure, okay?
Okay.
What is that?
Data backup, disaster recovery, and data replication and fault tolerance. Is this are services provided by Azure or cloud?
Good answer. Together, what are they referred as?
Sir,
Together, what are they referred as?
services.
Okay, how about this one?
Increase or decrease resources and services based on demand. Scalability.
Okay, scalable, good answer. How about this one?
Automate scaling during spikes and drop in demand. Scaling during spikes, drop in demand. Auto scaling.
It's called elasticity. Okay.
Okay. The underlying hardware and managed software is patched, upgraded, replaced by the cloud provider without interruption to you. Upgrade or replaced by cloud provider without.
What do you think is the meaning of that, Sri Rupa?
If some of the machines are failed, then they will replace by cloud. Fault tolerance.
Okay, that is the current. The current means the latest software, any of the patches and things like that are getting automatically upgraded by the cloud service provider. We don't have to take care of that one, okay?
Okay.
So, let's do a few more here. Let's say, okay, see. You're on mute.
A product that is run and managed by the service provider. Don't worry about how the service is maintained. It just works and remains unavailable. It's available.
Oh, I'll give you a hint about this one. Let's see.
Office 365. It works and reminds available. Software as a service.
Good answer. That's a software as service. Okay. Okay.
Focus on the deployment and management of your apps. Don't worry about provisioning, configuring, and understanding the hardware or OS. Deployment and management. Provisioning, configuring. Platform as a service.
Good answer. Okay. How about this one?
The basic building blocks of cloud IT. Provide access to networking features, computers, and data storage. Don't worry about the IT staff, data centers, and hardware. Infrastructure.
Good. Sorry, 1 minute, Srirupa.
Okay.
Okay. Can you try to explain what is this slide, what we are doing in this slide, Srirupa?
First one is the features or maybe services. These three are difference between infrastructure, service, platform, software services.
Okay. So on-premise, customer is responsible.
Okay.
In infrastructure service, what is the dark blue difference between dark blue and the light blue?
Dark blue is responsible of customer. Customer is responsible.
Dark blue,
Customer is responsible.
the light blue or the dark blue?
Dark blue, sir. Light blue, sir. Customer is responsible. Just confused.
Okay, one moment, please. Oops. Bringing this up. Sharing again. Okay. What do you think this is? What is going on here, Sri Rupa?
Cloud 19. The cloud cloud native. In Azure network, we are using public and private subnets.
Oh, sorry, I was on mute. Let's see. Do you know what is network, Srirupa?
Network is a group of machines
Group of machines connected with each other. Okay.
connected to each other.
What do you think is subnet?
Subnet is a part of one machine in that network.
What do you think is the difference between public subnet and private subnet?
Public subnet is accessed by everyone. Private subnet is accessed by only who have access on it.
Very good. What is shown, what is displayed inside private subnet?
It's a database.
Very good. Do you know why they put database inside a private subnet?
By using this database, we perform actions on public subnet.
So generally, database is not exposed to the public. What is inside what is the icon inside the public subnet?
It's a computer.
It's like a virtual machine.
Other virtual machine.
Inside the virtual machine, they generally put the web applications and things like that. So the architects generally, what do? That's how they design. In public, we will expose the web applications to the public. The web applications are internally accessing the database, which is within the business or the enterprise. Okay, so the web application is accessing the database, not the public. If the public want any data, if the outside people want any data, they don't give access to the database, they give access to the web application, okay?
Okay.
What do you think is VNet?
Virtual network.
Why do we call it virtual?
We can't see.
In other words, the network is on the cloud.
Okay.
Not inside our premises, okay? So if everything is built on the cloud and it is called cloud native, what does that mean? Everything is on the cloud.
Okay.
What do you think it means?
Sir?
What do you think it means?
Public cloud.
Everything is on the cloud.
Okay.
All your company, they have put everything on the cloud. They're accessing via virtual network. It's not, it's as if the network is inside your company, but the network is really in the cloud, right?
Okay.
Okay, let's see. Read this and try to see if you can answer this.
I think built-on company data centers, also known as on-premise. The cloud could be OpenStack. On-premise data. Hybrid net cloud.
Why hybrid?
On-premise used in hybrid
On-premise. Okay. So that is private cloud.
Okay.
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 Let's see. Okay. What is going on here?
Here we are connecting on-premise and cloud servers
How are we connecting?
by routing.
We're using Express Route Service. Okay. Express Route Service, we need to is connecting the on-premise network to the virtual network. What is this called?
Hybrid.
It is hybrid. Okay.
Okay.
Okay. Let's see where we are. Okay, we still have a few minutes here. Oh, sorry about that. I was on mute again. So I shared it. Okay. Take a look at this one. Try to explain each of the things here, Sri Rupa.
In public cloud, it is cost effective. Might not meet security requirement.
Why is it cost effective?
In its infrastructure managed by cloud. Security controls by default might not meet security requirements. In public cloud, we have some of the default security options, but we are not getting all our security requirements.
Can you think of why? That's a tough question. Okay, that is one of the disadvantages of public cloud. Because no, it is not in our control, as simple as that, okay?
Okay.
Read the next one.
Develop configuration limited based on what the cloud service provider exposed to you. It is a limited cloud service. Technical knowledge. You don't need in-depth knowledge of underlying
Why do you
infrastructure.
say it is limited, Sri Rupa?
Based on what the cloud service provider.
Because we are just taking what they are providing. We may not be able to get everything that we have on premise, okay?
Okay.
Technical knowledge?
Here infrastructure managed by cloud, so we don't need that much of knowledge about.
Very good. Okay,
Private cloud.
explain.
Private cloud, it's most expensive
Until why?
because here we are responsible for infrastructure. We buy the infrastructure. No guarantee it's secure. Can meet any security compliant requirement if you put in the network. There is no guarantee for security in private cloud.
Why do you say there is no security, Srirupa? Why do you think so?
It's managed by server, I think. So that's why.
Because the entire setup is on the cloud and we have taken the complete ownership. We do not know if anything can go wrong. So that's why they're saying guarantee is not secure, okay?
Okay. You can configure the infrastructure however you like. In private cloud, we are the responsible for infrastructure, so we can configure however we like.
Answer, because we are private, everything we are responsible, everything is
Okay.
only for us.
You need to know the in-depth how to configure all levels of. So here we are responsible for infrastructure, so we need to know the knowledge about it.
So because we have taken it private, it's only for us. We are managing everything. We are taking care of all the infrastructure also. Nobody else is using the cloud. We are responsible for everything. And we need to know, unless we know in depth, we should not go for private cloud, okay? Okay, next one.
Hybrid could be more cost effective based on what you offload to the cloud. Hybrid cloud is a cost effective. Here we are using cloud server and connected to the on premises. You now have to secure your connection to the cloud. You can meet all security requirements. In hybrid cloud, we just connect the cloud server and on premises. So we just secure about that connection.
Okay, in hybrid, we're connecting both the private, the on-premise data center with the
Azure cloud service.
public cloud. So we're using Express Route. Express Route is secure. If you don't use Express Route, anything else will be our risk.
Okay. You get the best of both worlds.
Why do we say we get the best of both?
So here we are using public and private servers. So that's why
Okay, as simple as that.
you need to know in depth how to configure all levels of your infrastructure and know the CSP servers. So we just have the knowledge about the infrastructure.
Okay, again, similar to private cloud, we need to have an idea about what are all the hardware requirements and the other kinds of infrastructure we will need to connect with the cloud, and we need to configure them. So that's why we need an in-depth knowledge, okay? Okay, so gentlemen, ladies, for today, I'll stop it here. Let's continue the journey from tomorrow and we'll go from here, guys. Let's see. Yeah. Everybody okay, guys? Quick yes, please. If possible, if time permits, please try to go over some of our Azure questions and things like that. There are some changes I'm making to some of the slides. I did not upload them. I'm planning to put everything together and upload them. So give me maybe today or maybe tomorrow, I'll upload the rest of them, guys, okay? You guys stay safe and keep learning and stay safe. Signing off for today, guys. Thank you and bye for now. Thank you again.